let's solve another sum based on multiplication of matrices and transpose of a matrix. Yeah. So the question tells us if matrix A is equal to 2, 5, 1, 3 and matrix B 4, minus 2, minus 1, 3 and I is the identity matrix of the same order and A to the power t is the transpose of matrix A, find A transpose into B plus B into I. Right. So let's start with the sum. First things first, we've been given the value of A and in the final answer we require A transpose. So let's find the transpose of value of A transpose. So we know one thing, that A is equal to 2, 5, 1, 3. So if you guys remember now, this would mean that A transpose, this implies A transpose, right? If you guys remember, transpose is nothing but turning the rows to columns and columns to rows. So 2, 5 is our first row, which becomes our first column, and 1, 3, which is our second row, will become the second column, right? So this here is the value for A transpose, right? Now we want to find the value of A transpose into B plus B into I. So first, let's find the value of A transpose into B, right? A transpose into B. So we have A transpose into matrix B, right? So that will be matrix A transpose, which is 2, 1, 5, 3, right? It's a little untidy there. Into matrix B, which is 4, minus 2, minus 1, and 3, right? So you want to multiply the two given matrices here. Now remember again, we are performing matrix multiplication. It's a 2 by 2 matrix, and this here again as well is a 2 by 2 matrix. So the number of columns in the first is equal to the number of rows in the second. So matrix multiplication is possible, and the resultant matrix, if I cancel these two out, I get is also 2 by 2. Right? So let's just write that here, a 2 by 2 matrix. Right? Now, remember, whenever you're multiplying two matrices, we consider the rows of the first and columns of the second. So let's just mark out our rows and columns so that it becomes easier for us to note them later on. So this here is the first row of the first matrix, second row of the first matrix, right? This here is the first column of the second matrix, and this here is the second column of the second matrix. Now let's perform our multiplications. Whenever you want to multiply, so 2 by 2 matrix, so first row first column element will be the multiplication of the first row and the first column. So multiplication of the first row with the first column, don't forget, element wise. So 2 into 4 gives me 8, and 1 into minus 1 will give me minus 1. So 8 plus minus 1. I'm directly writing the values now because 2 into 4 will give me 8, 1 into minus 1 will give me minus 1. This is the first row first column element. Now we are moving on to the first row second column element. So that will give me 2 into minus 2, which is minus 4, and 1 into 3, so plus 3, right? Further on, now we're done with the first row. Let's go on to the second row. For the second row, it will be the second row first column. So 5 into 4, which is 20, and plus 3 into minus 1, which is minus 3, right? And moving on to the second row second column now, 5 into minus 2 is minus 10, and 3 into 3 is 9, so plus 9. There you go. I just need to simplify that, and that will give us the value of Alright, let's just keep it here. We've got some more space to simplify it. If I had to simplify this matrix here, I get the value for A transpose into B as, if you can notice, it is 8 plus minus 1, which is 8 minus 1, which is 7. Minus 4 plus 3, which is 4 minus, will give me minus 1. 20 plus minus 3, which is 20 minus 3 is 17. And minus 10 plus 9, which is 10 minus 1, yeah? So minus 1. Right, so this here is the value for A transpose into B. Next, I'll be trying to find the value of B into I. Yeah, so matrix B into matrix I is what we want to find next. Right, so matrix B is this column, matrix B into matrix I. Now, I, remember, is an identity matrix. If you guys remember when we were discussing identity matrix, I told you the identity matrix is a matrix that any matrix multiplied to the identity matrix will always give me the same matrix again. Here we will actually see that happening. So matrix B we know is 4, minus 1, minus 2, and 3. Right? This is our matrix B. And matrix I we know is 1, 0, 0, 1, the identity matrix. Once again, it's a 2 by 2 matrix. The resultant will also be a 2 by 2 matrix. And here we will see what our resultant will be then. So again, it's 2 matrices being multiplied, so it's going to be rows into columns. Let's mark our rows and columns. So first row of the first matrix, second row of the first matrix, multiply and mark our columns here. First column of the second matrix, second column of the second matrix. Right. Now when we perform our multiplications, for the first row, first column element, we'll be multiplying the first row and the first column. Right. So first row of the first into first column of the second. So 4 into 1, which is 4. Plus minus 2 into 0, which is 0. Right. Next, first row into second column. Right. So 4 into 0 is 0. Plus minus 2 into 1 is minus 2. Yeah. Now that's done for the first row. Now moving on to the second row. Second row into first column, we'll get minus 1 into 1, which is minus 1. Plus 3 into 0, which is 0. Now second row, second column element, right? So minus 1 into 0 is 0, plus 3 into 1 is 3. So if you have noticed here, if you see the elements that have popped out after multiplying matrix B and matrix I, is the same elements as matrix B. So 4 plus 0 is 4. 0 plus minus 2 is minus 2. Minus 1 plus 0 is minus 1. And 0 plus 3 is 3. So remember this. The identity matrix, anything multiplied to the identity matrix will give you the same matrix again. And we just showed that point here. Now, what we need to find for our final answer is basically A transpose times matrix B plus, was it plus? Where's the question? A transpose matrix B plus B times I. Alright. So A transpose plus matrix B plus matrix B. Sorry, let's use the color for matrix B plus matrix B times I. Right. we need to find the value of this, and we've already found the value A transpose plus matrix B. We've already found that to be 7 minus 1, 17 and minus 1. This is A transpose times B plus B times I, which is 4 minus 2 minus 1 and 3. Right, so now all we need to do is add two matrices. Matrix addition is rather straightforward, just add them element wise. So we have 7 plus 4, which gives us, let's just write the step down here, 7 plus 4 minus 1. So this is minus 1 plus minus 2, right? So minus 1 plus minus 2. 17 plus minus 1 in the next one. 17 plus minus 1 over here. And finally we have minus 1 plus 3. Minus 1 plus 3. Right, that's our matrix. Okay, so let's just write our final answer now. A transpose, final answer will be A transpose times matrix B plus B times the identity matrix I is equal to, that's our final answer, 7 plus 4 we know is 11, minus 1 plus minus 2 we know is minus 3, 17 plus minus 1 is 16, and minus 1 plus 3 will give me 2. Right, so this here is our final answer. The value for A transpose B plus B times I.